We have learned from their own internal reports that they are seeing about an 18% uplift in the valuation of their asset when they have improved the performance of that asset over in terms of energy efficiency. And so you can imagine on a $200 million skyscraper, you might invest a few $1 million on a new air conditioning system, and suddenly your building is worth almost $40 million more. And so that becomes this instant ROI, which changes the whole dynamic between a simple payback.
Welcome to Asia Climate Finance, your front row seat to the policies, investments, and actors shaping climate business and finance across Asia Pacific. Subscribe now so others find this essential guide to Asia's climate economy, and note the disclaimers at the end. Now over to the host, analyst, investor, and author, Joseph Jacobelli.
Good morning, good afternoon, and good evening, wherever you may be listening from. Welcome to Asia Climate Finance. Today we tackle a hidden giant in the global climate crisis, air conditioning. Most of us rarely think about it, but cooling accounts for a staggering 15% of global emissions. That is more than all of the world's internal combustion engine cars and planes combined. In many buildings, air conditioning gobbles up 2/3 of total power consumption. Joining me to discuss a radical solution is Sam Ringwaldt. Sam has spent 25 years at the forefront of clean tech. He has launched energy-efficient systems in North America, Australia, Singapore, and other places. And now, as the co-founder of Conry Tech, he is on a mission to reinvent a technology that has barely changed in over a century. We explore how modular micro-units can slash cooling energy use by up to 70%. We discuss the surging demand for AI-driven data centers and why retrofitting existing building is the fastest way to hit our climate goals. Sam also explains the business case for comfort as a service and how energy efficiency can boost a building's value by almost a fifth. It is an insightful conversation about moving from mechanical decisions to financial ones. As always, if you have any comments or ideas you would like to share, please send them to the email at the top of the show notes. Enjoy the discussion. Hello, Sam. Thank you so much for making the time for the Asia Climate Finance podcast. I really appreciate it.
Very much my pleasure. Thanks for having me.
So how's everything down in Melbourne? The weather, I guess, is getting less hot now.
Well, it's Melbourne after all, so we just had a severe rain squall just come through, which lasted all of a couple of minutes, and now it's cleared up again. So, as they say, 4 seasons in a day.
Get more than what you bargained for, I guess. Sam, could I just start a little bit with your background and how you got interested in climate tech or clean tech or whichever derivative of you want to call it? Yeah, a little bit about you and a little bit about how you got interested in this sector.
Well, I've had the privilege of talking about sustainability and about driving energy efficiency for longer than it's been cool. So almost 25 years ago now, I embarked on a mission to take a new air conditioning technology to market across North America, literally going door to door in a mobile showroom to show people this radical new technology that was going to save them so much energy on the air conditioning system. And so for the last 25 years, my career has been introducing new energy efficient, better air conditioning technologies to the world, which has given me stints in North America, Australia, 10 years in Singapore. I've really had a mandate.
No, talking about right now, Sam, for those of us who haven't come across Conry Tech before, including yours truly, sorry, what's the kind of elevator pitch? What problem are you actually solving and why does it matter right now?
Well, my co-founder, Ron Conry, from which we have borrowed his name, much to his horror and protest, he is an incredible inventor that has just developed a range of technologies in air conditioning that, whilst people would not know of, they would have experienced in virtually any building in the world. We've cooled literally billions of square feet of buildings around the world with these past technologies. But what we were doing in the past was taking the worst part of a system and making it better. And so about 6 years ago, we decided that it was time to throw out how air conditioning was done, get rid of the limitations that had always been there and start again. Because the big problem is that air conditioning is about 2/3 of a building's power consumption and already about 15% of global emissions. And those numbers are growing. And
15%, is that? Wow.
Yeah, it's a radically high number, more than all cars and planes combined, just our comfort. And you look at markets like India and Indonesia where air conditioning usage is still scaling up exponentially. If we keep doing it the same way we've always done it, we're just going to cool ourselves to a much hotter planet. And so it was time to tackle it wholesale.
Interesting. So Sam, air conditioning is obviously not a new technology, right? What is it about the way it's currently done that it's so fundamentally broken? And why hasn't the industry fixed it before now?
Yeah, so air conditioning is just over 100 years young now. So it's been around for a little while. And 100 years ago, or just before air conditioning that we know it today was introduced, an iceman would come and drop off a big block of ice at your building. The water would melt off that ice and you'd have fans that would blow across that. And the big innovation that the air conditioning industry did was to come up with a machine that could make that cold water that then could air condition the building so you didn't need the iceman anymore. But the bones, the infrastructure of how you built up your system and how you distributed that cooling around a building has actually not fundamentally changed. If you picked up a technician from the 1920s and put them in a plant room today, other than there being big fancy screens they're not used to, the technology itself is largely similar. So the industry is a very slow-moving industry. People rarely think about air conditioning unless it's not working. It's one of those trades that people know very little about. And so there's never been much external impetus to change, which is perhaps why the previous technologies we've brought to market had so much success, because they fundamentally fixed certain parts of the system. But even with those, we stayed constrained with the same rules of how it's always been done. And so really, this is the first time that even we ourselves have taken a step back and said, if we were to invent air conditioning today, what would that look like? And that's what's driven us to a fundamentally new approach.
Interesting. So Sam, what does exactly Conry Tech do? I mean, what's your technology? How are you addressing the problem that you mentioned?
So we've invented and patented a new approach to air conditioning, where instead of treating a building as one homogeneous whole, where the lowest common denominator wins, we have created hyper-efficient micro modules that allow us to decentralize air conditioning. So we want to bring the system closer to where people need to be comfortable. Basically, we want to deliver how much heating or cooling, where it's needed, when it's needed, and only just as much as is needed. And in doing so, we radically reduce how much power we're going to use, anywhere from 2 to 5 times more energy efficient than current systems, whilst genuinely improving comfort for everyone.
And does your solution work in any kind of circumstances? And just using one particular example, obviously commercial buildings are one of the major uses of air conditioning, but data centers have also been in the headlines of recent because of how many have been built around the world. Now, commercial buildings and data centers are quite different beasts. One is about human comfort and the other is about keeping servers alive. How does Conry's approach work across both? And is the underlying technology essentially the same?
There's probably more similarities than people might anticipate. Servers also like to operate at temperatures very similar to where humans are comfortable. And every human being is in fact a heater that walks into a space. And so however hard you're working, if you've been running, if you're working out in a gym, for example, you need more cooling than you do if you've just been sitting watching a movie. And likewise, a server that's working hard running an AI engine or doing some graphics rendering or something requires a lot more cooling than a server that's handling your online banking transactions, for example. And the main difference between the two is just concentration. So if you took a meeting room that currently had 10 people in it, and now for a data center in that same space, you jammed 1,000 people into it or 1,000 servers into it. Now you're starting to get the scale difference between commercial and data. So data centers still have fluctuations depending on how hard the systems are working. A little less fluctuations than people walking out of a building to go on lunch or going home at the end of the day, but still have fluctuating loads that need to be managed. Still, ultimately, we're trying to keep the space conditioned to a comfortable temperature for either a person to work in or for a server to continue to work well in.
Got it. You I think in your website and your materials, you talk about reinventing air conditioning. So when you talk about reinventing air conditioning, are we talking about a retrofit solution that works with existing infrastructure, or does it require a full rip and replace? That's often the make or break question for building owners, right?
No, we're predominantly aiming at retrofit. So there's far more existing buildings in the world than there are new buildings being built. And so our system offers a lot of additional advantages. If you did adopt it at the early stages of a design of a new build, you'd get even more benefits from it. But our primary market will always be retrofit, either into existing data centers or existing commercial buildings. Really any building larger than a house is sort of our target market. So the difference really is just how many of our units, because we've made it micro and modular. One small building might require 10 of our units, a big building might require 150, but it's the same system just being deployed to deliver with precision what is required in that space.
So just to understand it from my kind of simple non-engineering perspective, what about old buildings, especially in Europe, right? We have a lot of very old buildings where actually even putting normal air conditioning is very, very complex and very difficult. Does Conry Technology make that easier in old buildings where installing a normal air conditioning would be very difficult?
Yeah, dramatically easier. In fact, one of the challenges, particularly in those old historical buildings, is you really can't punch a 1 meter by 1 meter hole through a wall to bring a big air duct through. Whereas we're delivering most of our energy through a water loop that's around the building and from each room. And so that's a matter of running a hose or a small pipe through. So drilling an inch hole is a very different proposition to cutting in a 1 meter square hole through a wall. And so it makes it a lot easier. You could retrofit it even piece by piece in a building. You would use existing cupboards that are there to hide the units away in or up in the ceiling space. And so you could systematically go through and retrofit a building without very much disruption. One of the huge challenges, and one of the reasons no one ever thinks about chillers, is they're huge devices. I mean, picture something the size of a truck that's getting buried away in the second or third basement of a building or up on the roof. And so typically every installation I've been involved in over the last 20 years has been in the middle of the night, roads blocked, helicopters bringing equipment in, huge trucks and cranes. But by the morning time, everyone's out of sight. And so no one thinks about how complex it really is. Our new device is the size of a small esky or cooler that you could put on a trolley and wheel into the building. So it's a whole different proposition.
Oh, wow. So that also occupies a lot less space than, say, a heat pump, right? Because, I mean, I'm not, given my lack of engineering background and just general naivety about the whole thing. I mean, I think like a normal heat pump in a small house of 150 square meters or something over 2 floors, the heat pump will actually probably be slightly bigger than me. So we're talking about something quite big. So I presume that in a bigger complex, the heat pump will be sizably bigger. So again, that kind of, in terms of space, your solution is a lot smaller than a heat pump as well, right?
Yeah, look, the total net area across the whole building is probably similar, but it's a more manageable component to deal with. So they can be hidden away internally in a cupboard or so on. You're not trying to find room externally to hang things off the side of the building. They are all having to reject the same amount of heat, no matter which system you do. And so the total amount of heat exchange surface will be about the same. But yeah, it's a more manageable size to do it. I mean, think about, like, if you were delivering 100 lunches from the local lunch restaurant, Subway or something, It's a lot easier to deliver that on 100 motorbikes than a big truck with 100 lunches in it going from place to place. And so it's much the same mindset, changing from that mainframe to PC mindset, changing from that bulk delivery to micro delivery type mindset. That's really at the core of our innovation.
Just going really quickly and briefly back to data centers, because again, it's in the headlines. So maybe we should spend a couple of more minutes on it. So data centers are obviously having a moment with the AI boom, driving enormous demand for computing and, of course, enormous demand for cooling. How are you positioning? How is Conry positioning itself to capture that wave, and how do you talk to hyperscalers versus a property developer, for example?
Look, it's a different question, but at the end of the day, the main driver behind either customer is economics. This is not necessarily an altruistic sustainability play. We don't need people to care about the environment to help save the environment. We need people to have the economics of this drive it. And so whether you're a data center looking to lower your total power consumption on site, which is what you can do by improving the efficiency, which is your main overhead against what it costs to compute. Or if you're a hotel looking to minimize your electricity bill for the property so that your energy per room night is reduced, or if you're a supermarket, no matter what you are, your energy costs end up directly impacting the bottom line. And so every dollar I can remove from that bottom line directly flows into a positive impact on your EBITDA. And so now the conversation becomes far more of a financial one. And that's part of the process that I've been walking different types of clients through over the last 15, 20 years, is trying to move what has traditionally been a mechanical decision into a financial decision. You're trying to demonstrate to a CFO or a CEO, why are you allowing this plant room operator to make a $2 million decision on a piece of equipment, where if you put in the right equipment, we could be saving you $1 million a year, for example, which is directly positive on the EBITDA. So the conversations are slightly different for a hyperscaler than a thing, but really they're also different between a hotelier and a commercial office building, between an office building and a school. It's about adopting the language to meet the problem. But in all of them, the ability to provide cooling or heating with precision and doing it with the new hardware that we've developed that makes it far more energy efficient ultimately translates back into dollars in their pocket.
Can we, on that subject, can we talk a little bit about numbers? What kind of energy savings or emissions reductions do you expect in future your customers to see? What are your kind of like rough projections?
Well, it may shock you to learn that about 2/3 of a building's power goes to air conditioning. And even if you analyze your annual bill across the year at home, you would find probably similar thing. About 2/3 of what you spend on energy goes to heating and cooling. And so we've projected about a 70% saving for most buildings. And so
70.
So if you multiply that out by the 60%, we're talking an almost 50, sort of a 40 to 50% reduction on the total power bill. So if you're currently sitting in a high-rise commercial building spending $1.5 million a year in power, you would expect to virtually halve that.
Wow. Okay. In terms of still talking about kind of the finance and financing side of things, so from a finance and financing and investment perspective, how do you structure the commercial proposition? Will customers be buying the technology outright, or is there a service or energy as a service model that makes that CapEx conversation easier?
We're really trying to pioneer something I'm calling comfort as a service. So a more subscription-based, so energy and hardware-based subscription, where we can manage your total energy consumption, like that bill, as well as delivering comfort or delivering the right conditions to your servers or whatever. That will work in much of the world. It won't work necessarily everywhere. And so we will equally have sort of a direct sales typical model where you can invest the CapEx up front. The interesting thing in the financial calculations, though, is that we're not talking purely about a energy savings funded installation. So it certainly could be, if you did the maths based on that measure, you're talking about 1.5 to 2 years typically as a payback on any delta you would pay for our system over a different one for a retrofit. However, when I've been engaging with a lot of large multinational property developers, we have learned from their own internal reports that they are seeing about an 18% uplift in the valuation of their asset when they have improved the performance of that asset over the in terms of energy efficiency. And so you can imagine on a $200 million skyscraper, you might invest a few $1 million on a new air conditioning system, and suddenly your building is worth almost $40 million more. And so that becomes this instant ROI, which changes the whole dynamic between a simple payback.
So if it is going to be like on a quasi-subscription basis, or if that is one of the possible models, how can Conry source capital? And will there be any kind of financing long-term plans, or do you project that you will even need long-term funding?
In the long term, potentially not so much. It should be a highly profitable business and so able to largely self-fund. However, the rollout that Comfort as a Service subscription model at scale, likely we need to set up a special purpose vehicle that's well funded so it can buy the equipment from our manufacturing entity and then deploy it over long-term leases. We're seeing leases in developed markets like Singapore, for example, for cooling as a service now, spanning to sort of the 20-year mark. So people are signing 20-year subscription agreements for their cooling. And so we would expect to piggyback on that same sort of mindset that's emerging. And we will also need, in addition to that though, we'll also need a bit of shorter term capital. So venture type capital likely as we move from our final stages of development into full commercialization, just to set up the factory and set up sort of scale production as we go to market.
Right. Can you tell us a little bit of where you're at now, like in terms of the kind of evolution of Conry Tech? Because you mentioned that you have to set up a factory or whatever it is. Could you explain that a little bit, please?
Yeah, so we're on a slightly accelerated journey for a deep tech type hardware technology. So we're about 5.5 years into our development cycle at the moment. What that means is we're really coming towards the end of that cycle. So we're a little ahead of time, perhaps benefiting from the numerous times we've done this previously. And so within the next little while, we'll be going into field trials and then setting up that initial production line and so on, and then going to market. So within the next, 2 years from now, we should be in market and starting to grow. But you have to set up the production facilities, obviously, somewhat before that. Fortunately, because the device is modular and small, it also means we can modularize our factory expansion. We don't need to pay now for something that can do 100,000 units a year. We can simply add capacity as we grow, largely self-funded from profitability.
And that's going to be in Australia or not necessarily in Australia?
Look, our aim is to establish sort of a headquarters manufacturing plant in Australia. I think longer term, we'll also need to put one in Asia somewhere to service that market. That's definitely the fastest growing market that we aim to serve, as well as perhaps one in North America that would serve the Americas somewhere. But I think from that basis, potentially we add one longer term in Middle East or Europe or somewhere, but that would be a little further down the track.
Well, given climate change, trust me, Europe will need it sooner than you may think. Actually, I think I read somewhere saying that by 2075, a massive percentage of workers in the UK won't be able to work because it's going to be too hot. So I'm not really I need to look at I'll put the link to that article in the
Look,
show
they'll
notes.
definitely have added air conditioning before then. Because what we're seeing in markets like Europe, in places like Germany and others, where traditionally they had 3 hot days of summer where they would not sleep very well,
exactly.
and they would survive. Those 3 days is becoming 3 weeks or a month, and you can't just not sleep for a month. And so the demand for air conditioning is certainly on the rise in Europe. But we're talking about more extreme weather events everywhere, both heating and cooling. And our system does both. But a lot of the growth is still going to be overshadowed by the sheer volume of growth in a market like India, for example. India currently has something like 15 to 18% of their buildings currently air conditioned. And yet we're also seeing the most extreme hot temperatures. And so their need to add air conditioning is changing from it being a luxury item to now a necessity, because you need it to study, to sleep, to heal. I mean, it's becoming a necessity of life rather than a luxury.
But also the number of deaths. I mean, I know the number of deaths in Europe, number of deaths in India has been rising because of you're getting temperatures were absolutely crazy. Wasn't there like almost like 50 or 45 degrees or 50 degrees Celsius in Sicily last year or something?
Yeah, look, it will definitely impact heat-related deaths. I don't talk about that too much because people rarely mention the cold-related deaths are diminishing, and so there is a bit of a net balancing going on where the colder regions aren't taking people out and the hotter regions are. But we shouldn't be satisfied with either. I mean, we should be. It's definitely within our power and within the technology that exists today. Those are avoidable deaths, and so no matter what the net total is, they are numbers we should be diminishing.
Moving on to the outlook, Sam. Looking out 5 years or maybe 10 years, what does success look like for Conry? And more broadly, do you think the built environment sector is moving fast enough on decarbonization, or are we kidding ourselves right now? It's a very broad question.
I think we definitely could accelerate, but there are so many options to choose from that they have competing claims, which make it difficult for a building owner to decipher the substance from the noise. Air conditioning, however, you will find now on the top of every emissions report, and as more and more companies are doing that, they're going to find air conditioning is their number one line item. People are getting more and more data now as they're installing more equipment to monitor and measure where power goes in the building. And so there's a real awakening that I'm seeing fairly well globally of the understanding that air conditioning is this huge thing. So in 5 years' time, what I'd love to see is there's recognition globally that there's a better way to do it, that we don't need to be satisfied with 60% of the building's power going to air conditioning and yet still leaving everyone uncomfortable. And I don't think we should be pursuing technologies where we sacrifice comfort for the sake of efficiency or for climate. I think any solution that requires behavioral change or requires an altruistic sustainability buying mandate is inherently flawed. And so I think technologies like ours that move the needle radically, it's almost the low-hanging fruit that no one's been talking about. If we can reduce air conditioning consumption by 70%, this is a radical step forward for the built environment. And if we don't do it, as per the IEA's projections, 50% of the global growth in energy consumption from now till 2050 is going to be air conditioning. There's something like 10 new air conditioners being installed every second from now till 2050. If we keep installing the same ones we've always done, we simply can't build renewable power stations fast enough to keep up with the growth in energy consumption. So we have to do it differently.
Right. That's the great conversation, Sam. I'm fascinated, and apologies for all the very naive questions. Obviously, need to go back to school and learn more about air conditioners. On the lighter side of things, I was wondering if by any chance you have any recommendations. Just could be a book, could be a report, could be a movie, could be a documentary, or anything else that you'd like to recommend to listeners.
Would it be cheeky to recommend your own book back to your listeners?
Actually, I already had that in a couple of the podcasts. Yeah.
Look, I think there's actually
a little bit cheeky. Yes.
I think there's a lot of material out there, but I think a lot of people are getting their content now from AI. So if you want to ask Claude or ChatGPT or whatever your flavor is, what's something that you could do that would meaningfully reduce your impact on this planet and that you could do economically, I'd be very surprised if it doesn't spit out some suggestions about air conditioning. And so that may well be a good place to start. And I'd welcome people to follow us on our journey as we bring this new technology to market globally. And if anyone can assist us in any way or wants to explore that in their own facilities, yeah, I'd love to hear from them.
Great. Well, we'll have your website and any other material in the show notes. We'll have a link to that. Sam, thank you so much for your time. Really appreciate it. And I do think that maybe a few months from now, maybe sometime next year or something, we can catch up again and see how the journey is going.
No, that'll be amazing. And I would just encourage anyone who's sitting there in the next few days, who's sitting there in a meeting that's, again, feeling too hot with too many people in the room, or they're sitting in a corner of the floor getting frozen by the vent above them. That is not something that long-term they should have to put up with. We should not have to sacrifice our comfort. We have the technology available to radically improve people's comfort whilst slashing energy consumption, reducing the associated emissions, and leaving this world a better place.
No, and one of the themes in my book is the fact that economics signals are taking over the policy signals, and that basically, if you look at the price of EVs, for example, there were a very significant premium even just 5 years ago, and now very similar prices. So the decision is no longer, I'm going to pay a premium to do something good for the planet, but it's just an economic decision, which makes sense. So I think with your solution, where you're saving, you said up to 70% of your energy costs, then it's pretty massive. So once again, Sam, thank you so much, and we'll have lots of links in the show notes to your company and other materials. Thank you so much, Sam.
Thanks for having me.
Please note that the Asia Climate Finance podcast is provided for educational purposes only and does not constitute investment advice. Any information discussed should not be relied upon for making investment decisions. Listeners should always seek advice from a suitably qualified and authorized investment professional. The views and opinions expressed by guests are their own and do not necessarily reflect the views of their current or former employers or of the podcast host or producers.